Good morning, good afternoon, good evening. Hope you're all well. So today we are going to discuss the second problem in the Codeforces Round 975 rated for Division 2. The problem name is All Pair Segments. So let's get started. Let's start by reading the problem statement first. You are given n points on the x-axis at increasing positive integer coordinates. For each pair ij, that is I is less than j, you can draw the segment x of I, x of j. The segments are closed. That is, both the points are included in that segment. You are given q queries. In the ith query, you are given a positive integer k of I. You need to determine how many points with integer coordinates are contained in exactly k of I segments. So we will be given n and a q. N is the number of points, q is the number of queries, then the integer coordinates that are on the x-axis, and then the k values. Like we need to output how many points are contained in these segments. Like if k is 2, like how many points occur in 2 segments. And we need to output q integers where the ith integer is the answer to the ith query. So let's understand the question by using an example. We'll be given an array of integers. Let's take this 6 and 7. These are the integers. We can have the following segments. Let me write the indexes also. So these can be the ranges. Right, so these can be the ranges. So whatever are the points between these, those will be the part of that segment. So let's plot these points on the x-axis. We have 1, we have 2, we have 3, we have 6, and we have 7. Right, so one segment would be this, one segment would be this, one segment is this, and another one is this. Similarly, we have this, we have this, and we have this, and we have this, and this, and this. So these are the segments. So we will be given an integer k. We need to output how many points would be part of k segments. Like let's see, like how many segments is 1 a part of. 1 is a part of only 4 segments, right? So for 1 we only have 4 segments. Let's have it for 2 now. 2 is a part of these all segments. So let's count them. 1, 2, 3, 4, 5, 6, 7. So 2 is a part of 7 segments. Let's count it for 3 as well. 3 is a part of these all. So 1, 2, 3, 4, 5, 6, 7, 8. 3 is a part for 8 segments. Let us also have 4, 5 here. So 4 will be part of these all segment and 5 will be part of these all. So these are these. So 1, 2, 3, 4, 5, 6. So 4 is a part of 6 and similarly 5 is also the part of 6. Now for this 6, this 6 we have 1, 2, 3, 4, 5, 6, 7. We have 7 segments, and for the 7 we have these 1, 2, 3, 4 segments. So these are the segments. Like this is the point, and this are the segments, and these are the segments. So let's suppose we are given k as 4. So we need to output what is the count of elements that are contained in 4 subsegments. So we have 4 here and here. So the answer is 1 and 7. The count of them is 2. Let's suppose k was 7. Now for 7, so it will be 6 and 2. The count is again 2. We need to output the count. Like we don't need to output the points, we just need to output the count. We basically need to show the count of these. Like for, let's see, so we'll make a map for this, for in which 4 has 2 elements, this and this, and 8 has 1, 6 has 2, 7 has 2. So this will be our map, and for each k, we will output the map of k. Like whatever is the value in the map. Like if the k was 4, then we'll output 2. If the k is not there in the map, then we will output 0. Right? So let's see how to make the map. Again, I'll be taking the same example. We are given 1, 2, 3, 6 and 7. So for 1, it was contained in 4 segments. These were the 4 segments, right? For this 2, it was contained in how many segments? It was contained in 7 segments. So what were those 7 segments? Let's draw them out. So this one was 1. This one was the second, this one was the third, this one was the fourth, this one was the fifth, this one was the sixth, this one was the seventh. So like how should we get this 7? Like we need to have a formula or a way to find this. Right, so for this, so what can we think? Like, so one thing we can note here is that this 2 would be included in that section that starts before it and ends after it, right? So how many segments start before it? So let's write it for the number 2. Like how many points are there before it? Before the points are 1 and after it we have how many points? We have 3 points. So we need to find a relation from this to this. So let's see what all are the segments. These were the segments. So we can have before plus 1 into after plus 1. Right? Why? Now what all would be these segments? So these would be these segments plus this will also be included. We need to remove this case. Like all the segments before and after, like all of them would be mapped to each other. This one would be mapped to this, with this, and with this. This one would be mapped to this. Like first this one would be mapped to itself, then it would be mapped here, then it would be mapped here, then it will go till here, and so on. Right? So like what's happening is these points would be mapped with these all points. This is the overlapping number, so we need to subtract 1 from this because 2, 2 cannot be a segment here, right? Because in the question itself it is given that I would be less than j, so we cannot have them equal. So the segments will start before the number and they can go till the end, right? So this would be the formula for the number of segments, right? Now let's apply this formula for a number here. Let's say 5. How many numbers do we have before it? We have 3 numbers, and after also we have 2 numbers, right? So let's have the number as 3 plus 1 into 2 plus 1, that is 4 into 3, that is 12. Now will it be included in 12 sections? So we have a 5 here, so 5 was included in 6 sections, right? And from here we get a 11, right? So this is wrong, like this fails here. So what should we do for the element that is not in the point? Right. So the problem here is that this one, we were including this one for this point, like since the sections were overlapping, that's why we included this one. We were adding one for these. Like before it was 1, but this would also be a section, right? This one. So but for the 5, this won't be a section. The segment would not end here, right? The segment would be like this only. It would not be like this. So it would be like this only, not like this. So we don't need to include this one here now. So our number would be before into after only, not the plus 1. So that is 3 into 2, that is 6. And that was the correct answer that we got. Like it was 6 initially also. So we have broken down the problem into 2 parts, part 1 and part 2. For a point inside in the array, the count is before plus 1 into after plus 1, and like outside not in the array, count is before into after. Now another thing that we need to note here is that this count would be the same for all the elements. Like for 4 and 5, this count would be the same. Why? Because the elements before and after are the same. So instead of calculating for all the points, like it could be given that 1, 2, 3, and then it could be 1000 here. So instead of calculating for all the points in between, we could just have the difference, like what are the number of elements in between, and we can have, let's suppose the count was C. So we can just have map of count plus equal to the number of elements in between. Like in the map, we are showing how many elements are there with a count of C. Count, right? So we can just add that number of elements in the map, so it would be easier. So we only need to iterate over this. So our time complexity would be big O of n, since we are only iterating over this once. We are not sorting it, we are doing nothing, we are just performing simple operations before and after. So it will be a simple big O of n, and it would get accepted given these constraints. So now let's look at the code. We'll have an input n and a queue. We will input the whole array. We will have a map of long and a long. That would be, so this map would have, what is the answer for map of k, right? So now we will iterate over the array from I is equal to 0 till n. Then for this, the element, we will have a before, that is I. We will have an after, that is equal to n minus I minus 1. Now we will have the count, like what is the segments, the number of segments it is a part of, that would be before plus 1 into after plus 1, and we will show the count, like the map of segments plus. Now if the I is greater than 0, that means we can have elements in between. Like for this array, there are elements 4 and 5. Before the first element, we cannot get any other element. So if I is greater than 0, so number of elements in between we'll calculate that. That is ARR of I minus ARR of I minus 1 and minus 1. These are the number of elements in between the two indexes. Let's suppose we take this. So 5 minus 3 minus 1. It is 1 element. So 4 was only present here. Right. So these are the number of elements, and the segments were before into after. And for this segments, I forgot to subtract 1. This subtraction was for the case where we'll have the same segment, like starts at 2 and ends at 2. We cannot have this point. So we need to remove that. That's why we are subtracting 1 here. But it won't be required here. And similarly, we will increment the count for segments. But instead of adding a 1, we will add the number of elements. Right? And for all the queries, we will print the value in map. If this is present, otherwise we will print 0. So this is the coding part. I hope you understood the approach. If you did not understand the approach, how am I doing this? Do watch it again. Like, how is this happening? Like, do watch how we are writing this before and after. Like, these segments, how is this being calculated? Do like write it down yourself once. Like, dry run this yourself once and you will understand. So now let's move on to code the same. I have my boilerplate code here. We'll be given an n and a q. We'll take both of them as inputs. We'll have a vector ARR of size n. We will take the vector also as input. We will make a map of long comma long. That let's not map. Let's include map also. Now I will iterate over the array. Now the elements before it were I and the elements after it were n minus I minus 1. I explained this in the explanation. So now we will have the number of segments. So that is equal to before plus 1 into after plus 1, and we would decrease 1 from the whole product. For the case where the starting and ending are the same, and we would increment that number plus 1. Now if I is greater than 0, then we will have elements in between, that is equal to ARR of I minus ARR of I minus 1 minus 1, and we will have the segments. Let's redefine the segments only into before into after, and increment the segments by the number of people in between, number of points in between. And now for all the queries, we will first take what is a value of the query. Let's say it's a. We will take that as input. Now if the map contains the a, then we will see out the value and a space. Otherwise we will just print a 0 and a new line in the end. That is our code. Now let's try it for the sample test cases. It failed. Why did it fail? Let's see. That is correct. So the error in our code is coming here in the segments part. Like, we have to do after plus 1. Why? Let's understand it using the same example. So this 5 would be calculated on this index. Like, the contribution for this 5 would be calculated on this index, and the after for this is 1. But for this, the after equals 2. Right? There are 2 indexes after it. So while adding in this, like adding here, we would have after plus 1. That was the error in our code that we overlooked. Now let's see the same in the code. So it would be after plus 1. Now let's try to run it, and it passed all the sample test cases. Now let's try to submit it. Submit code. The problem is B. It's paste and submit. It's in queue, running on test case 1, and it got accepted. That means our approach and our code was correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Like the video, subscribe to the channel, and share it with your friends. Thank you.